Hi, good afternoon. Today we'll be going on to tutorial 6 of the pure physics syllabus. Okay, so without much ado, let's go ahead with it. Right. So today we'll be doing what are the types of forces and is mass same as weight. So you need to know the difference, the similarities and what are the differences and the relationship between mass and weight. Okay, let's look at the first question. A spring balance. Okay, spring balance is always used to measure weight of an object. Alright, so therefore answer is B. Simple balance, sometimes they may also put it as beam balance. Or if you have seen it in your FNN classes, electronic balance. Alright, they are used to measure the mass of an object. The next unit for weight will always be newtons N. So answer is A. Alright. Mass will always be kg. Answer is B. So the relationship between mass and weight, in case you have forgotten, that weight equals to m times g. So when you use this equation, make sure your m is in kg, because your g tends to be in Newton per kg. Right? And therefore you will get your weight to be in new. Okay, the mass of a rock is 2 kg. So mass is the amount of matter present in the substance, so it's not affected by the gravitational field. So be it on Earth, on Moon, on Mars, the mass will not change. So the mass of the rock on Earth is 2 kg. Therefore, the mass of the rock on Moon will also be 2 kg. Now they're asking for question 6. Mass is still 2 kg. Right? It's on Moon. The G on Moon is 1.7. Sometimes they'll give you this. Sometimes they'll give you in Newton per kg. It's the same thing, right? Just like Earth, it will be 10 meter per second square or 10 Newton per kg. Therefore, weight is equals to mg, 2 times 1.7, yeah, 3.4. Answer. Now it's a bit tricky. It's going to be tricky. It's very similar, but instead of giving you the mass, they give you the weight of the rock on Earth is 20 Newton. So on Earth, weight is 20 Newton. G is 10 meter per second square or 10 Newton per kg. W equals to mg. Make m the subject. So W over G equals to m. 20 divided by 10 equals to m. M equals to 2 kg. So on Moon, your mass is still 2 kg. Your G is 1.7 meter per second square. Therefore, your weight is mg, 3.4 Newton. Option B. Object has a mass of 15 kg on the Earth. It's taken up to the Moon. The gravitational field strength on Earth is 10 Newton per kg and on the Moon is 1.6 Newton per kg. So the mass should not change, right? Mass on Earth and mass on Moon should be the same. Then the weight on Moon will be 1.6 times 15. Most of we get 24. So answer is A. the weight of, so moon, again, write down what info you have. Weight on moon is 200 Newton. And then the G is 1.7. So your mass is W over G, 200 over 1.7. So on Earth, the mass will be the same as on Moon. G is 10 meter per second square. W equals to mg. You'll get 200 over 1.7 times 10. Most probably you'll get 1. If you round to 3SF, will be 1180 Newton. Answer D. So they give you weight on 3 different celestial bodies. So celestial bodies could be your planets, could be your stars, could be moon. So don't be too don't worry about the words celestial bodies. So weight on moon is 200. Jupiter in 6,000. And Mercury is 400. Okay. Then they give you the G. On moon, 1.7. On Jupiter, 25.4. And on Mars, Mercury, 3.8. So your weight, so your mass would be 200 over 1.7. 600,000 over 25.4. And then your Mercury will be 400 over 3.8. So if you work it out, it's A, it's B, it's C. Okay, and you want to be ascending order. So this will be smallest. This will be your biggest. This one will be in the middle. Will be C, A, B. Small to big ascending order. If it's descending order, will be B, A, C. The answer is option B. Question 10. Okay, let's look at the open-ended questions. The acceleration of free fall near the surface of the Earth is 9.8 meters per second square. So it depends on the question. The most common will always be 10 meters per second square for acceleration of free fall. But sometimes they might put 9.8, 9.81, 9.82. So you need to take note of that in the question. So let's see. To find the weight of a mass 50 kg, W equals to mg, surface of Earth. So we use the acceleration of free fall for Earth, 9.8. Sometimes they'll call it acceleration due to gravity. It's the same thing as acceleration of free fall. So 5 times 9.8, you get 49 newtons. Okay, this one should be similar, but you'll be, instead of 5 times 9.8, now it's on moon. So it'll be 5 times 1.6, you get 8 newtons. This one a bit hard, look at it. So, an astronaut of mass 80 kg jumped out of the rocket after it landed on Jupiter. The astronaut took 4 seconds, 0.4 seconds to drop for 2 meters. What was the weight of the astronaut on Earth, on Jupiter? So you have the mass. To find the weight, you need to have the G. Right? To find the G, we'll go back to kinematics. So this is the velocity time graph. You drop, so initial speed will be zero, initial speed of velocity will be 0, and you take 0.4 seconds to land 2 meters. If you run a graph of velocity time graph is distance traveled, so this will be 2 meters. Hence we have this the triangle, right? So half times base times height. All right. So your base is 0.4. Your height is unknown v. So if you solve for it, you will get 10 meters per second. So now this is 10. Next, we can use this formula A equals to V minus U over T. 10 minus 0 over 0.4. You get 25 meters per second squared. Now, if you recall in your kinematics, when you drop the object or object falls vertically under free fall condition, the acceleration of the object is actually same as acceleration due to free fall or acceleration due to gravity. So the G on Jupiter is this. Therefore, we use W equals to mg, 80 times 25, I get 2000 meters. Right? So if you notice, we don't just use concept from this chapter, we also can use concepts from preceding chapters. Right? So that's why it's important to be familiar with all the different chapters. Okay, Jack and Jill are classmates collecting old newspapers as part of their school's volunteer work. Their goal is to collect 80 kg of newspaper from each block. They are assigned to. Jim wants to determine the mass of a stack of newspaper, but all he has is a spring balance. Jill comments that the spring balance cannot be used. So if you recall earlier in this lesson, spring balance we find weight rather than mass. Okay? So Jill correct. Is Jill correct? Jill is correct because Jill said that you can't use the spring balance to measure the mass of a newspaper directly. Because the reading on the spring balance will give you in newtons, and that will be the weight of the object you're trying to measure. So look at next question. Okay, so now Jim disagrees and say, hey, it can be done. So can the spring balance be used to measure the mass of a stack of newspaper? Explain. Okay, you cannot measure it directly, but you can find the weight directly from the spring balance. Right? And then using the formula, W equals to mg, and G on Earth is 10. So your mat W equals to mg. W over G will give you your mass. So yes, you cannot you cannot directly measure the mass using a spring balance, but by using the weight reading on a spring balance and using a formula, you can indirectly get the mass of the object you're trying to measure. Okay, this one just memorize. You need to beam balance and electronic mass balance or electronic balance will do. Okay, beam balance, if you have not seen it before, it's something like this. Then there's a cup here, and then there's a sliding weight here. Right, you don't really see nowadays, it's more used in older days. Electronic mass balance is just, it can be as common as your normal weighing scale you use in the gym or use at home. Okay, difference between mass and weight. This one, they like to ask, so you need to try to recall 2 or more differences. It may be. Okay, first is the definition. Mass is the amount of measure of the amount of matter in an object, but weight is the force of gravity acting on an object that has mass. Mass is not affected by gravity or gravitational field strength, but weight is. Also, third one, you can say mass is constant.